The best images from Artemis so far. More spacecraft are going to the moon. Researchers have simulated a wormhole, and China now has 6 people on board its space station. All this and more in this week's episode of Space Bites. So this is the 3rd episode of Space Bites, which has been recorded during an Artemis mission, which is kind of cool. And there'll probably be at least one more for Artemis return. So this is another update from Artemis. Now, the big thing to note is that we're just getting better and better video and photographs from the Artemis mission. So NASA released a giant supercut of the launch showing the perspective from the ground, the perspective from the rocket, showing the solid rocket boosters. And we had found some of the pieces of that video and highlighted them last week. But this week we got the NASA version, including a bunch of other pieces that we've never seen before. And I highly recommend that you go and watch the whole thing because it is awesome, very inspiring. We also got some really cool pictures from Artemis, which is now well beyond the distance of the moon. And it's looking back and you get these great pictures of the moon and the Earth side by side in the sky. And in fact, in one sequence, the moon passes directly in front of the Earth. And what's kind of cool is that the feed from Artemis cut off while it was going behind the moon, because of course the moon was blocking the transmission to Earth. And that's kind of exactly what you want. And I don't know if you've seen it, but you can actually go and watch a completely live version of Artemis whenever they're actually able to live stream it. It's boring. I mean, you just see sometimes you see the Earth, the moon, sometimes you just see space, you see the spacecraft itself, but it's live, which is the kind of thing that they couldn't have done back in the Apollo era. And yet, as NASA gets better and better at managing these missions, we're going to be able to see these live streams from deep space, which is so cool. So how's the mission doing? So far, so good. Today, when I'm recording this episode, they performed the burn that's going to bring them on a trajectory to come back to the Earth. They're going to do another flyby of the moon and then drop back down to the Earth and do their re-entry on December the 11th. But they've been testing. So there's 33 separate thrusters on board the Orion capsule and its service module, and they've been testing to make sure that all of these are working, testing different modes of flight that the astronauts might use. They've been testing its automated star tracker. They've been testing how well its solar panels handle various angles of the sun. Can it perform even when it's not in an optimal angle towards the sun? So they've just been doing a ton of tests to simulate what it'll be like when humans actually perform this exact same flight on Artemis 2. So far, everything seems to be going well, but of course, we're probably going to have to wait months, if not years, to get all of the data, see all the science papers, everything that they've been accumulating during this test flight. So we've got another week and a half before the spacecraft returns to Earth. So next week, it'll be passing the moon again. And the week after that, we'll be reporting on its successful landing or not successful landing, but I like its odds. More moon news. Actually, there's like a ton of things happening with the moon, not just the Artemis mission, but at the time that we're recording right now, a SpaceX Falcon is on the launch pad ready to loft a whole bunch of CubeSats towards the moon. One of these spacecraft in particular is called the Lunar Flashlight, and this is a mission from NASA that's going to be flying on the same trajectory as the Capstone mission, the same trajectory that the Lunar Gateway is going to be on, that will bring it close to the moon's south pole on a regular basis. And the goal of the Lunar Flashlight has this infrared laser on board, and it's going to be firing this laser into the permanently shadowed craters on the moon and then measuring as the reflected infrared light comes back out. And the goal here is to map out the size and shape of the deposits of water ice that are thought to be in these southern craters. And of course, these will be an essential resource for future missions to the moon that will want to be able to extract this water ice for fuel, for breathable air, and other supplies. So this is going to really map out the extent and locations of all of this water ice. Together with the lunar flashlight, there's also a Japanese lander called the Hakuto R. And actually, this was one of the contestants for the Google Lunar X Prize, which got canceled because nobody was able to actually land on the moon within their time frame. One of the other landers was, of course, the Space IL's Bearsheet lander, which crashed into the moon. But hopefully, this one will be successful, and so we should see a landing on the moon as well. It's really appeared, though, that landing on the moon is very difficult. I mean, we saw that the Bearsheet lander had a problem. We saw that India's lunar lander had a problem. Then there was a Japanese lander that was part of the Artemis 1 mission that we've lost contact with. So landing on the moon is not as simple as you would think. And yet, of course, the Chinese have done some successful landings. So it's not impossible. It's just tough. But hopefully, if all goes well, this time next week, I'll be talking about the successful launch of the Lunar Flashlight and the Hakuto R mission. NASA is also thinking about infrastructure on the moon. What about all of the landing pads, roads, buildings? And they recently awarded a $57 million contract to a company called Icon, which is out of Austin, Texas. And they recently won a few awards for their ability to 3D print structures using simulated lunar regolith. And so they were able to demonstrate that they had the kind of thermal properties that are required, that they was able to seal it for the atmosphere. And so in theory, when we go back to the moon to stay, a lot of the structures that are going to be on the moon, they're going to be built on the moon out of local material. And so NASA has demonstrated their commitment to this strategy by hiring this company to help develop the technology. And so you can imagine some future mission will go to the moon and this rover will gobble up regolith and then 3D print out roads and landing pads and eventually build the kinds of structures that the astronauts will live in. And this is just a snapshot. I mean, I could just do this whole show talking about all of the really interesting missions from many different countries that are getting developed to go back to start exploring the moon. So it really feels like this time we're gonna stay. Researchers simulate a wormhole. All right, you've probably heard quite a bit about this story already, and I feel like my job once again is to be the downer and to bring your expectations down. But that said, it is kind of interesting, so I want to go into this. So researchers announced this week with a lot of fanfare. There was a paper in the journal Nature. They did a 20-minute documentary on their work. There's been a lot of press releases. And what they claimed is that they have simulated a wormhole in a quantum computer. And that feels like a lot of high-tech gibberish. So let me try and sort of explain what they've actually done. So they created this system in a quantum computer with two separate instances that were entangled inside this quantum computer. And then they fed quantum bits, qubits, into one of the systems, and they appeared on the other system. In other words, they traveled through some kind of quantum wormhole. But they didn't actually do this. This is a simulation inside a quantum computer. And in order to do this, they had to inject this idea of negative energy, or the computer equivalent in their simulation of negative energy, to make the whole thing work. And of course, one of the big problems is that in the real world, negative energy isn't a thing. And we have no way to make it, and we may never have a way to make it. So they did not make a wormhole, but they were able to simulate a wormhole using quantum computing. And so in many cases, creating simulations is one of the first steps to making a thing in real life. So it's an interesting step forward in actually getting to a point where we might see wormholes in the future. But we reported on this with Universe Today, and some of the scientists who are familiar with this used fairly colorful language to describe what they thought of this research. So I would remain very skeptical that this is going to go any farther than that. I mean, we're just going to need to find negative energy to really make any of these sci-fi dreams come together. And so even if they're able to actually make this work in their simulation, it doesn't mean that it will actually really work. It's just math. Very interesting math. Math that's done in a very interesting way on a quantum computer. But it's one thing to have a simulation, and it's quite another thing to have this work in reality. More images from JWST. It's funny to me when people say, oh, we haven't seen a lot of pictures from JWST. Have you not been watching our channel? I mean, I feel like we share 1 to 2 cool images from this telescope every week and talk about the really cool research that's going on. So wouldn't be another week with Space Bites without more images from JWST. So the first one I want to show you, this is Galaxy NGC 1566. This is the image from JWST. And then just compare what this looks like if you look at it in the visible wavelength, say from Hubble. And you might be getting familiar with the color palette here. This is another eldritch horror color palette from Judy Schmidt, who I interviewed here on the channel a few months ago. And what's really interesting about this is if you look, you can see these faint areas that are red, and those match to star formation in this galaxy. And in the Hubble image, a lot of the regions that we're seeing in this image are actually shrouded by dust. The purpose of JWST in this case is to show off where the dust is, where the regions of star formation probably are. And that's what JWST is perfect of. But I really love, it's a face-on spiral. We look right down to the heart of the galaxy. We can see this bright, dusty knot at the center, and then these 2 spiral arms radiating outward where all of this star formation is happening. And then last week, we showed you a preview image of Titan captured by JWST, but we didn't have a lot of information on it. And when I showed the picture, I wasn't even sure what was what. Is this a cloud? Is that ground? I don't know. So we got a more official response from researchers this week. This was observations that were done by both JWST and the Keck Observatory. And the Keck Observatory, that's 2 10-meter telescopes side by side in Hawaii, one of the most powerful observatories on Earth. And it was able to produce a really impressive infrared image of Titan, and then you can compare that to the images coming from JWST. So you can really sort of see how the features match up between these 2 observatories. And we got labels. So now you know what some of the objects in this image are. You can see clouds in the atmosphere of Titan. You can see surface features like the Kraken Mare, which is at its northern portion. And so even though this is a fairly small little version of Titan, it's revealing features that we've never seen before. You probably enjoy the videos that we do here on our YouTube channel, but did you know this is just like the tip of the Universe Today iceberg? This is just like one little part of what we do. We have a website where we publish news nonstop. We have a weekly email newsletter that I write that goes out to more than 55,000 people. We have podcasts and other media that you can enjoy. And the best way to support us is to join our Patreon. This gives you advanced access to videos that we do. You get to see behind the scenes. If you join, I will remove all the ads from the Universe Today website for life. Your support as one of our patrons allows us to remain a completely independent space news website. So join our community, go to patreon.com/universetoday. Black hole consumes a star. One of the telescopes that I'm most excited about is the upcoming Vera Rubin Observatory. It'll come online in the next couple of years, and it's going to be scanning the entire southern sky every couple of nights, looking for anything that changes. It's going to see variable stars, it's going to see asteroids, it's going to see supernova, things like that. Actually, there are versions of this observatory already operational, and one of these is called the Zwicky Transient Facility. Just like Vera Rubin, it scans the sky every 2 days or so, looking for any flashes, anything weird, unusual, and reports it to astronomers. And recently, astronomers using this instrument detected a bright flash in the sky, and they sent out the alert to astronomers. Astronomers did follow-on observations, specifically with the European Southern Observatory's Very Large Telescope, one of the very largest telescopes in the world. I know, the names. And what they were able to determine is that they're looking at a supermassive black hole that is in the process of consuming a star. So the star is coming very close to the black hole, and each time that it does, a bunch of its material goes into the black hole and it releases this yelp of gamma radiation that we're able to detect. And astronomers calculated that it's releasing about 1 trillion suns worth of energy each time it goes through this process. And this isn't just a one-time process. The black hole is just constantly feeding on this star as it goes around and around. It's probably consuming about half of the sun's mass every year, and we'll keep doing this until the star is gone. What's amazing is just how bright this is. They were able to determine that the light has been traveling to us for 8.5 billion years, and yet this object is as bright as a gamma ray burst, more bright than gamma ray bursts. And so an extreme event like this just shows you how much energy there is out there in the universe. Unlike the sun, which is going through fusion, which is actually a fairly inefficient process, you're just taking this star, you're feeding it directly into a black hole, you're blasting out enormous amounts of radiation, which is a lot more closer to like the pure E equals MC squared energy relationship. The universe is terrifying and awesome. We only see an event like this about once every 10 years. Because we don't have a great way to scan the sky night after night to find these kinds of objects. But when Vera Rubin comes online, we will be finding many, many more of them. I really want this telescope to come online. We got the launch of a new Chinese spacecraft this week, Shenzhou 15. And this was carrying 3 astronauts, taikonauts, to the Tiangong space station. And in addition to the 3 astronauts, they were also bringing a bunch of experiment racks that were going to be attached to the space station. And with this process, this officially completes the end of the construction of this space station. There's now 6 people on board the station, but only for about a month, and then the previous crew is going to be returning. But China now plans to have this station be continuously inhabited for the next 10 years. And when you think about the overlap, like the International Space Station probably won't last too far into the 2030s. So we'll probably only have the Chinese space station with astronauts in space for a few years. One more interesting mission is they're going to be launching the Xintian Space Telescope. This is like almost a Hubble class telescope. Originally, they were thinking they would actually dock it onto the space station, but the new plan is it's going to fly close, so they don't, I guess, shake the telescope while it's trying to do long duration observations. But then they can bring the telescope, dock it to the space station, make modifications, add new instruments, repair it, etc., and then release it again. And we should see the launch of Xintian in 23 or 24. Another big test for SuperHeavy. This week we got another test for the SpaceX SuperHeavy booster. This time it tested 11 of its Raptor 2 engines, firing them for 13 seconds. Although this wasn't a dramatically bigger test than they'd already done, they actually had been upgrading the infrastructure around the launch site. So hopefully they'll be able to create a facility that can handle regular launches from a rocket this powerful. Now, Musk was talking online about what happens next. He said that there's going to be another test where they're going to fully fuel the oxygen tanks on the booster, which is for the first time to sort of see if it can handle the full pressure of the oxygen tanks. And then we'll probably see another static fire test, and then we'll see an orbital test. But I stand by my prediction. March. We'll see. In case you missed it, we did a really cool collaboration for our 200th question and answers show. I asked everybody for their brutal questions, and that's because I had no plans to answer these questions. I was going to hand them off to my space friends. So we got cool answers from a whole bunch of famous space YouTubers to answer your questions about space and astronomy. It came together really well. It was so much fun to have people answer questions very different from the way I would, but so good. You're going to see names like Scott Manley, Sabina Hasselfelder, Joe Scott, a lot of the people you're very familiar with. So definitely check out that collaboration. And thanks to everyone who both asked questions and to all of the space YouTubers who joined in and answered questions. All right, those were all of the news stories that we had today. As usual, there's going to be links in the show notes down below if you want to find out more information. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 55,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Josh Schultz and Andrew M. Gross who support us at the Master of the Universe level. All your support means the universe to us. All right, that's all the news for today. We'll see you next week.